Another straightforward one, number 7. List the 3 requirements for a correctly written chemical equation. This is one of this and number 6 are both objectives for the entire section. So I hope you can do these. We talked about these in the lecture very specifically. But a correctly written chemical equation must represent known facts. If you don't know that water is produced as a result of combustion, you're not going to be able to balance that equation properly. For example, if we're going to have some sort of hydrocarbon and we are oxidizing it, right, rapid oxidation, you might be well aware that CO2 is created. But here's the thing. If you are unaware that H2O is also being generated, when you go to balance this equation, you're not going to come up with the correct coefficients. Okay, it's going to mess you all up. You're not going to get the right molar ratios. You have to have these extra hydrogens and that extra oxygen in there to actually go about balancing this correctly. The second thing that we need, the equation must contain the correct formulas for a few things. For reactants and products. Okay, for the reactants and the products. Basically everything that's going to be in the reaction equation. The example that I gave during the lecture is the idea of oxygen. You know, if we're aware that oxygen is present, okay, for example, there's oxygen present right there. If we're unaware that oxygen is a diatomic molecule, and so that molecular oxygen, meaning the type of oxygen involved in a combustion reaction, is O2, and we think it's just O because O's name is oxygen, and we're unaware of this diatomic molecule idea, that's going to screw up our balancing as well. We're going to think there's only one oxygen here when there's actually 2, and that's going to majorly mess up our coefficients, our molar coefficients, just as bad as this first mistake is going to. Lastly, we need to satisfy the law of conservation, I can spell, of mass. Now this is really nice because the law of conservation of mass is really, really simple. It says whatever is on the reactant side, you need to have present in the exact same numbers on the product side. And the nice thing about it is that it sounds very impressive. It's very official, very powerful. Makes it sound like you know what you're talking about. But all you're really saying is, hey, whatever's on that side of the reaction arrow has to be on that side of the reaction arrow. And remember, this is how you go about checking your answers when it comes to balancing equations. You make sure that the law of conservation of mass is satisfied by having the same number of each type of element on each side of the equation.